Alright, we're live. I am a little bit late once again, but that is always kind of just how this ends up going. I'm also completely out of sticky notes now, which makes me really sad, but whatever. Yeah, so this is day 85 of studying compilers every day until I land a compiler role. I am like really out of it today. I'm like really tired, so today's stream might be on the short end, but like actual real short end. Yeah, so last time I think we finished Shigen for the most part. I'll need to double check that. And that's like great in some way, but this means we have to get to the actual substantive stuff now, which is a little bit less enjoyable. So I need to update, I guess, our tree representation and kind of figure out what's happening there, but it shouldn't be that bad, I think. Yeah. So we need to do that. I also need to like add print stuff to my LIR. Yeah, and then of course we can test everything, and then we should be good to go. I think most of the difficult stuff here has been worked out, which is really funny because my solution to all of it has just been literally push it off to the future for when I do actually need to like deal with the rest of it, and it's just, that's gonna be really funny. I have some ideas on how to do that, but we will see how that goes, I guess. So let's get straight into it. Yeah, so last time we finished most of tree gen, I think, if not all of it. Just to double check, let's open up tree gen, or gen tree trees. Let's look up to do. Yeah, so we just have these. So this one I'm not sure about yet. This one I'm not sure about yet. This I think will pair with the first one, and then this one I'll do eventually. So we just have those 4 to-dos left, which is really nice because I think that means we are in a very good spot. Yeah. Okay. So yeah, I guess we can kind of, I guess, move forwards into the next part. So if we go back to the MIR to LIR sort of pipeline, what we do is first we generate trees, and that kind of covers the whole set of instructions. And then we can use those trees to kind of merge, or we can merge on the, I cannot speak. We can merge those trees into, I guess, larger trees, and then that allows us to produce a more, not precise, more efficient, I guess, instruction selection, or more efficient use of instructions when we're generating our first layer of assembly, at least. Yeah. So I guess I should probably like give a little diagram as an example, or maybe like, yeah, maybe paint on this a little bit troll. Yeah, let's make a new thing. Or yeah, let's just split like this. Okay, so we can do this. So let's go to like, I don't know, one of our like tests as an example. Or yeah, I guess that might be good. Let's look at like the MIR for something. If is definitely going to be too complex to be interesting. Oh, this might be interesting actually. At least, maybe the basic memtoreg will be good. We can probably simplify this a little bit at least. Maybe we could just, yeah, that folds everything down, huh? Okay, we're gonna be very reductionist, and I think we're just gonna use like this, or, I don't know, give me a second, I need to find a good example. In the meantime, how's everyone's day? Hopefully everyone's doing good. We can just make an example. So let's do like function test. I'm just gonna do this as an example. I don't know. So this has like var one or var I equals 1, and then like b equal, wow, very consistent. We can do this, b equals like, let's do like 5, and then like var c equals like, I don't know, 4. And we can do like return c plus, or we should do like b equals b times 4, or b times c. We're going to just do this, skip the c there. And then a equals a plus b, and then like return a as an example. Just as like a sample program. Let's make things a little bit larger. I'm adjusting this by hand because I don't know the bind for that. Yeah, okay. So the code that this would generate, if we were, I guess like, I can kind of like walk through this a little bit by hand. Or maybe we could like, I don't know, what else can we do here to make this interesting? Let's make like, let's give it like a as a parameter actually. Yeah, we can do that, I guess. Yeah, something like this. So we have like, if we were to turn this into like instructions, we would have like, reg equals load a, or like percent a equals like load a is like the parameter, I guess, or I don't know. We can do that, and then like, so that like, that deals with like the parameter load. We can do like reg2 equals move 5, I guess. Yeah, we can do that. And then wanna multiply it by 4, so like reg2 is like mul, like let's do like reg2 and then like let's simplify the syntax. Yeah, this will. I just wrote this. Okay, we're gonna have a reg2 file or temp2 file somewhere. That's gonna be really funny. Let's just like, I don't know, what am I doing here? Okay, we need like a better way to do this. Let me think. Okay, let's just skip the parameter altogether. Okay. Or like we could give it like I here or something. Yeah, so we have like, let's start over. I'm like really struggling today. Yeah, so we have like load or mov I into like a. I'm just gonna add arrows so we're like very concrete about which way things move. Yeah, so we move that into A, we move 5 into B, and then like, yeah, and then I've already structured these in this sort of way as kind of like, we can kind of like, I guess, two operand structure this in a way, so it'll be a little more convenient for this part, because that's kind of how assembly does things. So we can do like mul b. Yeah, so we can multiply like 4 b, and I know this is like not necessarily how multiplication will work, but as an example, I need to look up the semantics of that. Yeah, so we can do that and then add B to A. And then like we have to like move into the relevant register. So like move A to like RAX. Let's make these more explicitly registers real quick. Okay, we can do that, and then we can like ret as an example. So that is like the first level of, I guess, the first level generation. This is like basically what we've done so far. We have this, not necessarily like one-to-one this, but we've basically generated like individual instructions out of everything. And yeah, it might seem like this is all we need to do for instruction selection, but we can definitely do a lot better. And yeah, so we have like a tree representation of these. So we can replace each of these, or so we have 1, 2, 3, 4, and then 5 instructions. Yeah, and each of these gets like their own tree. This gets its like own thing because, well, I didn't make a tree for this. That's kind of like the special case assembly node thing. All of these we can do like, we can represent this as a tree. So like A is a move, and then that takes an I, or load, I guess we can think of like that. Or actually, what's my tree type again? Oh, I saved both of these. Unlucky. Okay. Let's check real quick what I have. Where did this all go? Node. Registers, immediates, op, allocate, load. Load, store, fee, asm. We probably do need a move node, huh? Or is that an op actually? No, it's definitely not an op. Okay, we need a way to do that then, I think. But it doesn't really need to be like one-to-one at least, I think. Yeah, so this is just gonna be like a fictional, like, I guess, tree structure, because our code doesn't really allow for this code to exist. This will, if we were to like write code like this, it would all just get folded down into the A. So this is like a little bit of a contrived example, but hopefully it'll make some degree of sense, at least big picture wise. Me barely knowing arrays, watching a guy learn compile is crazy. I mean, I think that's like fair. It's all like pretty cool stuff, and I think at least like a lot of this can be kind of understood. If I'm going too fast at all, just like let me know and I can like try to explain things differently. What's good, Darius? Good to see you. Okay, so we have A, and then this is like a move node, and then this takes like I as an example. So that's what that is, and then we have like we can just do like param there. So then we do like B is a move, which is a 5, I guess, like this. Yeah, and then this can be represented as, so we have B, and then that takes a mul node, and this takes 4, and then a B. Okay, and then this node we can represent as A gets like add, and this takes A and then B. And then we have like this assembly node, sort of. That's like, this is like kind of what we would generate out of the initial like tree generation step. So the next one is we can merge these. So I did like a little bit of research into this off stream, and I have a little sticky note with everything on it. So there's like a couple of rules at least. And the big thing is we want to make sure we preserve correctness. So so they all have to be like with, I guess, like sequential to each other. or at least like the block that we're looking at. So then we have, I think these two might be like what we want to merge, for instance. So we want an instance where, so we have, I guess, tree 1, which is this one, and then tree 2, which is this one. We want to merge tree 2 into tree 1 when it is, or wait, no. Other way around. So we have tree 1, which is the second one, and we have tree 2, which is, I don't know. Just for simplicity, I'll make the top one tree 1, the bottom one tree 2. We want to merge tree 1 into tree 2 when it is a safe operation. And tree 1 or tree 2 uses a variable that is defined by tree 1. What's good, Aiden? How's it going? Hopefully your code prep is doing well, or at least you're like taking a break. Following outline of Fortran 1 compiler is something different. I'm kind of just like freestyling with some book references for a C compiler. I'm trying to compile from C down to x86-64. Yeah, so we have these two trees, we want to merge them. So let's just like pull these out real quick. So it's safe to merge when the variable that we care about, which is this b here, which we're matching against the b inside here. If this variable, it has no uses after this ladder instruction, and it's only either that or it's strictly only used by this instruction, I guess. Little break for Domino's. We gotta get the 670 pizzas. That's a good deal. Yeah. So in this instance, this instruction is safe because we don't use b afterwards. Or we do use b, but it's a different b. So yeah, it's a little bit convoluted here, but yeah. Or I think, actually no, we would merge this up first and then we'd merge this up. So there's another b after this, so we can't merge this safely, but what we can do is we can merge these bottom two safely. So I'm gonna pull these out. So at the point where I'm just looking at solutions and hoping things stick, yeah, I mean, that's kind of fair. I think like, yeah, I think at this point you've kind of like gotten most of the LeetCode value that you can get out of it already. So I think it's fair to just like chill for a little and just make sure you're like mentally prepared. Quant dev interview soon. Ooh, any advice? First of all, I will give a disclaimer that I don't think I'm very knowledgeable about just like broader quant interviewing broadly, just because like I'm like while I am looking into like quant, it's like kind of, I guess, a subset of quant, and that kind of narrows the amount of interview prep that I would be doing at least. I will say, I think a strong knowledge of like networking, OS, writing concurrent and parallel code, all of those are important. Being very familiar with the language and the tech stack that whichever firm it is uses is also very important. Yeah, I think those are probably good places to study. I'm sure you can evaluate which of those you're like the weakest on, and then just like spend most of your time touching up on that, and then just like doing a little bit of polishing around the edges. I think that's like the big pile at least. And then like LeetCode's always LeetCode, so be sure to do that as well. Yeah, let's merge these two trees. So we got this B here, we got this B inside here. Yeah, we have those two B's, so we can literally just take this pile and then we can replace this B in here with that. And then let's get rid of that B, and there we go. This is one tree merged, so we can replace these two with this tree. Yeah, so now that allows us to merge this other tree in, because we have a B here, we have a B here, and then all of these B's are, I guess, not used beyond this point. Or there are no uses of B beyond this, so we can we can safely merge this in at least. So we can delete this B. We can find this B in here, and then we can paste over it pretty much. And this is how we generate a tree slowly. Let's get rid of some of these parentheses to make things a little bit less awful. Yeah, okay. So we have this now. We can merge another layer even, because we're not looking at this assembly pile. This is kind of just like, you can think of this as like a barrier at least. So we're only looking at these two instructions. There's no use of A after in like this, I guess, quote unquote mini scope. I don't really have a good term for it. So we can safely merge this A into this A in here. Yeah, so let's take that. Let's paste over that, and we can delete that. So this is the final state of trees that we have for this program, roughly. So yeah, that's like the second part, and that's like the part that I'm hoping to implement today. Trying to write a compiler from TypeScript to MIPS assembly. I write lexical analysis without using a library. Yeah, that writing that with JavaScript might be a little bit annoying, just because JavaScript, I guess like if you're comfortable with JavaScript, then like fair enough, but it feels like a language that is just not really tooled for the task, at least in my opinion. Oh man, wait, I just got a crazy thought. Is the TypeScript compiler in TypeScript? I really hope it's not in TypeScript. Oh no. Oh no. Oh, that's gotta be awful. Right? Where is the compiler at least? Because if the TypeScript compiler is in TypeScript, I would feel bad for anyone that had to work on it. Or I guess now it's a runtime, right? So it's like fine. Like it's still annoying, but it seems at least workable. Is it this? Notes. The TypeScript compiler notes is in JavaScript. That's quite humorous. Okay, let's look at binary. TSC. Let's look at lib. Glup. It's not here. Let's look in here then. Oh god, this seems not fun to work in. Yeah, this is all in TypeScript. That's terrifying. I guess we're not doing any like crazy code transforms, so it's like still fine, but yeah. Just for fun, I'll find an internship, like to try something else. That's fair, yeah. It's definitely fun just to like work on projects. I feel like if I were to just like spend a summer working on projects and not like care about employment, I would definitely have way more enjoyable of a time. But I mean, life is life at the end of the day, so I gotta get employed somehow. So yeah, it is what it is. But yeah, the fact that the TypeScript compiler isn't TypeScript is really funny to me, because that implies we're using TypeScript to write a compiler. And again, this is not to bash you or anything. It's just like, it's really funny to me that a production level compiler uses TypeScript. But like, if you're writing like a toy compiler, use whatever language you like. Hell, even use like Python. Just go nuts. Just have fun with it. Yeah, anyways, back to my little explanation here. Yeah, so we've taken this, we generated trees. Let me just like separate this out a little bit more clearly. Yeah, so we have that, and then we have that. So step 1, generate trees, and then step 2, merge trees. Let's just like, we can give this like a big brace around it actually. Something like that. Yeah, something like this as an example. So now that we have that, we can go down to step 3 now, which is tiling the trees. And this is how we generate the assembly. Yeah, so we have this giant tree here. The idea is we want to find, I guess, the most efficient instruction to cover the tree that we have here. And if you know anything about assembly, you will find that there is a very specific instruction that this example was written around. x86, 64, LEA. Oh, that's a flashbang. You know what? Yeah, we'll use that website. What are you working on? I'm kind of just like explaining the idea behind my instruction selection stuff right now, because I've never like formally gotten a chance to like explain it. This page does not go dark mode properly, so we will just have to scorch our eyeballs a little bit. There should be a, yeah, so this thing here. So it takes like 3 operands. I guess like we have it's used to like calculate an effective address without following it. So it basically does a multiply by multiply by 1, 2, 4, 8, and then it does it adds another value to it. Yeah. So then yeah, so we can use that to kind of cover that tile. I think there's a very specific syntax that I'm looking for from this. It's like this sort of thing. Yeah, something like this. So we can use it to do all sorts of crazy stuff here. And this is what will, I guess, tile here nicely. So if you look at what we have a multiply inside here, and then we have an add pretty much. So we can, yeah, so we can tile one level of this at least. So I guess we can start with this. I guess it'd be easier if now I go to paint.net and draw this out. And again, my explanation is like really convoluted, so like apologies. But this is all like, it's all like low-key hard to explain. Yeah, so we have reg A here, and this is a add node, or let's just do a plus. So this takes a move node, and this takes param, or let me just give like param as an example here. Yeah, and then from then here, then we have a multiply node, or let's just make like a star. Is that how you write an asterisk? I need to look at my keyboard. That's not how you write it. Damn it. It's like this. There you go. Yeah. So this is a 4, and then another move, I guess. Yeah, okay. So with this, we can take this instruction and we can kind of like represent it as a tile. And if we think about like what the add and multiply would cover, this would all be like predefined, and I would probably like draw out a bunch of different tiles, but just for brevity, I'm gonna kind of just greedily tile this, like, or I guess I should like tile this tree kind of like this, I think. And this is all covered by that one LEA instruction. So this is like, It's like LEA, reg A, and then this takes like move, or this is like move param. It's like whatever goes in there. Yeah, we can do like param, some sort of move. Yeah, we can like, I guess we can tile this as well. And we just like finish the tiling, the tile coverage. So we have these tiles, and they all have like one node of overlap, which is enough to, I guess, like the correct way to cover the tree. So we have like, if you give these numbers, we have like, in reverse order, it's like 1 and 2 and then like 3. Let's use the correct colors actually. 1 and 2. If I can like draw the tail properly. Okay, and then we have 3. Yeah, so this covers like, so it takes percent A, and then this takes so then 2 plus 2 plus 1, or reg 2. Okay. First try. So we present 2 plus percent 1 times 4. And that's what the LEA will cover. And then above this we can, I guess, vomit out these tiles. So we have like, yeah, MOV. Let's make this more explicit. 1 second. So this is an arrow this way, I guess. Let's just erase this real quick. Yeah, arrow like this. Let's also like make this a little bit smaller for the ambiguity. Okay. So now we want like reg 2 to get whatever is in param. And then last one, we want to move 5 into 1. So we have like reg 1, and then this gets 5. Yeah, so that is like our final, I guess, our final assembly that we get out of this. And you'll notice that it's a lot more, or at least to cover this. So it ends up a little bit more compact at least. So we have like, so we have 5 to some reg here. We'll just do like A now. Or I think there's a way we can like skip the move even if we just make like a bigger tile, to be honest. Yeah, we could in theory just cover this all with one giant tile and handle the moves like that. So then yeah, that's actually something I need to think about. Yeah, so 5 into A, we have into like B, and then like LEA. So we want like B, and then like it's an A times 4, or something like this sort of format. And this goes into, alright, we can't use A because we're already using that. Whoops. C, this is B. This goes into like A now because we have A like left over. Yeah, and then we can steal the assembly from up here, and then that goes in here. Yeah, so it might not look like we've done a lot, but this is like a way more efficient instruction than if we were to just like do like macro expansion, I guess. So that is like the rough idea of what I'm trying to do here. Yeah, let's just remove these. Okay. That's not the right button. Okay, cool. So now we can go here. We can, for better or for worse, start trying to do all that stuff. At least the first part of that. The second part I need to think about, but we can start figuring out how to merge trees, and this seems a little bit daunting. So yeah, I don't think I have a great idea yet, but we will give it our best shot. Explanation also took me half an hour because I'm quite rusty. Okay, so we want to implement this merge trees thing. These should be on the opposite windows. Okay. So we want that. We could kind of do like, I don't know, I kind of want to do like exhaustive search here. Oh, let's go to Alex. Thought I'd give an update, did not make it to the Tiramisu World Cup. Aw, unlucky. There's always next year. You got it. Okay, I don't know how I want to do merging here. Maybe we could do like one pass, which is like uses of, or like we need a way to represent like the variables each tree, I guess, uses and generates. So how do we do that? Oh, it's liveness analysis. Okay, our good friend, it's always here. Liveness analysis. I guess with SSA this is a little bit silly though. So it's yeah, it shouldn't be that bad at least, because we have a lot of copies at least. Oh boy. Okay. I guess, yeah, I don't know. How do I even go about this? I guess we should probably, where are tree classes? We have get leaves. Maybe we just generate those and then we can like figure that out in the merging once we get there. Yeah, we have a list there. This does not seem like a very optimal data structure for this though. I don't know. Surely it's alright. Okay, so maybe we should like, we do need to just do a linear search, I think. Oh no. Or no, we could do a linear search of like children nodes, I guess, or of leaves, which is a little bit less bad, but it's still quite bad. Okay, let's make leaves a unordered set instead. Do we have list anywhere else? Yeah, we do. Okay. So unordered set. Alright, so we can do that. That will help us very substantially. Okay. So now I think we can create like a tree. We could do like to tree for each of the nodes, right? Or no, we already generate this, I guess. Yeah, I guess we need to like, yeah, we need to set leaves somehow because we haven't really set that yet. So I guess we still need to work on gen trees a little bit. But I'm not really sure how to do this, at least. Alright, what type is function trees actually? Or these are all list a tree. Wait, what? What is reg? Oh, this is gonna break, yeah. This is definitely gonna break. Do we even use a tree here? Or a tree type? No, we just don't. Okay, that's a big problem. Yeah, okay, that is quite problematic. 'Cause that means we're just sticking nodes into trees, I think. Alright, we're kind of just like sticking node unique pointers into a tree list, which is very bad. So we need to update gen trees to fix this up. Okay, so then some assembly notes. So this is that. Okay, so we want auto tree equals did make unique tree. This just takes unique assembly. Right? Yeah, okay. Yeah, so then this just takes tree. Yeah, and that. Wait, what? What type is function trees? Wait. What? Wait, that doesn't make sense to me. Oh, wait, no, wait, I'm dumb. Wait, we're emplacing back. Wait, I am quite stupid. So we are actually just making it. Okay, so we want to do that, and then... What return type is in place back? Is this a thing? Can you guys just take a ref from that? Yeah, okay. So we can do that. And then tree. Yeah, and then we don't need to do anything here. But for the other ones, we need to like... we need to update the, I guess, like, leaves of the tree. Yeah, anything with assembly node is fine already. This one we need to update. So I'll do that. This is a ref. Okay, so then we want this. Yeah, so we have leaves, and then we wanna give it left and right, I think. Or wait, did we change the header of tree? Yeah, that should be that now. It should be unordered set. So we can't really do this now. Instead, we want to in place, and then we give it we want left and right, I guess. Yeah, so that doesn't exist yet or anymore, but we can just like take pointers with it. Yeah, we can do this, and we can do the same for right as well. Yeah, so we want left putter. What type is this? This is... Or wait. What is in place take? This is not what we care about. Insert. Right? No? Wait, why are these unique putters? Or, wait, what? No, these are node putters. Right? Why the hell? Oh no, they're unique pointer putter. Oh my god. Oh, that's vile. Oh. Why did I do this again? There was a very concrete reason for this. Oh, so we could just move the unique pointer. Oh no, okay. Can I do a ref instead? Okay, we'll just do a pointer. I don't know, this is really gross. Okay, we definitely can't do a ref. So we just have to do a putter then, I guess. Oh no. Okay. So we want to steal these, but we want to like do these down here. So we want like up. Or actually, okay, move does not change a pointer. Okay. So can we kind of just like do these become no pointers after? Can we just insert like left? Or can we do this and then can we just insert right as well? Yeah, let's ask ChatGPT this. Hopefully it can provide something useful. Is this C code break? I'm trying to save the pointers. I'm not sure if move make invalidates them. Oh my god, do I need a unique pointer of a unique pointer now? Holy shit, what am I doing? I want to make it so I can move the pointer by merging this here. Wait, what? Wait, this is not what I want though. Okay, I might just need to like do tree traversal until I find. Oh no. This is terrible. ChatGPT is trash? Yeah, I mean, but I also have no idea what to do here, so it beats having nothing at least. Okay, well. What does stud move? Or wait. Oh wait, okay, yeah. So the move itself is safe, but the operation that consumes the move is not safe, I guess. Let's go, Janine. Good to see you. So we're not copying. So we're just We're making a project, or is this? I assume you mean like a class project or a personal project. Yeah, this is completely a personal project. Oh, that's crazy. I guess that makes sense, but still. Okay, so then I guess, how do I even do this? Because these are unique pointers, and they're like chained, at least. What's your project name on GitHub? It's called Panic. It should be pinned on my GitHub at least. Tree store ref, please. Shared pointer? God damn it. This is, I don't know, this is not very helpful. I guess it's really hard for me to look up what I actually want to do here. I guess if I need to traverse it anyway, there's no point in keeping leaves, at least. Yeah, I mean, this seems a little bit tough. What are you building? I'm building a compiler from x86, or from C to x86 64. Right now I'm working on instruction selection, and I'm struggling to figure out the data structures here because it's not really like one-to-one linear with anything. We might not be able to do this get leaves thing then, actually. Yeah, I'm fairly sure these will break at least. So maybe I start using shared pointers here actually. This is crazy. These might have to be these might have to be shared pointers. Nice, I'm also building a compiler with LLVM. Ooh, fun stuff, yeah. Are you enjoying the lack of documentation that LLVM has, or? Because I know that's at least one of the big pain points. Okay, let's use shared pointers. I think we finally found a use for shared pointers. What if I just use shared pointers? What do you mean complexity? This is cap. This doesn't matter because it's sequential. We don't have back pointers. This is fine, I don't care. Yeah, let's use shared pointers. I've never used a shared pointer before, so this will be very interesting. Okay. This will be quite interesting. so many unique pointers. Haven't seen a compiler rule in tech market. Is it rare? Yeah, to some degree. But if you look up compiler jobs, I guarantee there will be at least some semblance of a pal that shows up. Okay, let's use shared pointer. I don't know where I need a shared pointer, but we will figure this out as we go. This definitely needs shared footer. What's this, girls? I realized my previous idea of how to represent trees or do like a sort of skip list, but like on a tree. If you're like familiar with that data structure, or not even data structure, I guess like pattern. I had an idea for how to do it. I realized it wouldn't work, so I am making shared pointers instead of unique pointers now, and that should solve all my problems. Trees? Okay, cool. So the idea is like, I guess like with linked lists, like they're annoying to traverse. So some implementations also have like what's called a skip list, which is like, if you want to like skip n nodes, there's like, there's a corresponding pointer to that, whichever node that is. And that is nice because then you can, I guess, run your code less miserably slow. My idea is I want to do something similar with like a tree, but just skipping to the leaf nodes. And that way we can like make merging a little less awful. Unfortunately, it appears I am struggling a lot with how to do this. Because we can't really do like a ref2 what's it called? I'm really struggling to do. I'm struggling to use English. I lost my train of thought completely. My fault. Yeah. Do you have to preset skips? Yeah, you have to. At the data structure level, you have to manage them, but it's like updating an endpointer, sort of, except it's a tree now, so it's gonna make a mess. But yeah. Okay, so these also need to be shared footer. Yeah, and now I can say I've used shared pointers once, which is really crazy to think about. Actually, is there just an instance in here that I don't want to use a shared pointer? I think all of these I want a shared pointer for. I guess maybe not the fee. The fee is just gonna be an assembler. We're not generating fee nodes, right? Are we? I hope we're just generating assembly from that. Uh-oh, we're making a fee node. That's not what we want to do. Yeah, we should just make this an assembly, I think. That shouldn't cause any issues for us, because fees should be at the top of each basic block anyway. And that's also where like copies would go if we needed one, I think. So I think that should be fine, surely. I need to look more into SSA destruction to, I guess, get a better idea of how to do this, but yeah, it'll be interesting. I'm taking computer architecture. Unfortunately, computer architecture formally has been like kind of just outside of the scope of classes that I can take. I've always been like trying to put off like the intro to CE course just so I could like get a good prof for it, and then I just ran out of time for it. So I don't have the prereqs for it, unfortunately, but I have like some very vague idea of what happens at the architecture level. Like branch prediction is just like really stupid the way it works. You just the way it works is you just assume that we're gonna go on a certain branch and then just do the instruction, and if it turns out to be wrong, then you just undo the instruction, which is really funny. But yeah, that is roughly just like one of the crazy things that happens at the low level. It's a requirement? Ooh, well, let me know how it goes. I very much want to learn more about it, so that would be very interesting to me. Okay, I swear we had a phi instruction that we created in LIR. Because we need to represent this anyway, so it seems a little bit silly to use the phi for this at least. Also time for lineage? Fun. Yeah, I mean, lineage is just everywhere. That's one of the classes that you definitely want to just do properly, at least. Okay, so let's fix our mistakes. Let's get rid of phi node first. So we don't really need that. Let's also fix merge trees, or tile trees, I guess. Yeah, we don't need this anymore. Yeah, linear algebra is like water. It's essential to life, but I sure as hell cannot command it for the life of me. Yeah, it's important in everything. It's like everywhere in like every single algorithm for some god-awful reason. It's like the heart of machine learning. It's the heart of graphics. It's the heart of like game design. It truly is as essential as water. Unfortunately, I am not a waterbender, so I struggle to control it, regardless of how I even begin to attempt to do so. Yeah, it's a rather unfortunate life. Okay, so let's do the little assembly thing again. Do you speak Chinese? A little bit. I'm quite rusty. Where'd the error go? Oh, there it is. Okay. So we do this. We can like keep all the stuff in the middle at least. We can like replace this real quick. 2K subs? Yeah, it's really crazy to think about. When I first started streaming, it felt strange to see more than like 2 people on my stream at once. So like it really does mean a lot to me that y'all have so much support. Or sorry, all of y'all's support really does mean a lot to me, bottom line. Even if I'm like incapable of speaking competent English, I guess. Okay, so we have assembly. We want, we should make this operands instead. It should be operand star. This should be operand, I think. Yeah, we can do that. So then from, this should be LIR. This should be resolve operand. Okay, so we can do that. That's all good. Okay, so now we can make, yes, we do that, and then we need to actually add the phi instruction. So we want instruction, or auto phi equals, this is still a unique pointer, by the way, I think, because this is just a straight up instruction. Yeah, so that should still be safe. Are there compiler jobs where you might be here forever? I mean, that wouldn't be the end of the world, but yeah, there are definitely jobs. I've landed an internship for one. I don't count that as a full-time job, but there are a decent amount of positions at least, so it should be feasible at least by the end of next year. I really hope I could get one by the end of next year, actually, because that is when I graduate, and it would be a big problem if I didn't have a job after graduating. Stepping stone? Yeah, I know, but for the purpose of the series, it doesn't really count, at least. It still is, like, meaningful to me, but yeah. So compilers class in college, we wrote a Java compiler using Java. That's really cool. I guess Java is, like, the language of object-oriented programming, so it makes a lot of sense. Yeah, a lot of software engineering goes into compilers just because of how much stuff exists. and you want to make code as reusable as possible. So it makes sense to modularize it as much as possible. And I guess object-oriented programming, as much as everyone hates it, including me, it's quite useful. Yeah, it's quite useful for, what's it called? I guess managing projects of this scale that can be represented with objects. I still think like Rust's system kind of is just the best of all worlds, but yeah, object-oriented programming is like, it has its merits, even though everyone hates it. Okay, where's the fee instruction? There's the fee instruction. Okay, so let's do move source or from, and then we give it 2, I think. Yeah, okay. So we make the fee, and then we want instructions. I'm gonna push this back. Yeah, okay. So this is all we need here, I think. We just make a fee instruction now, which is less awful. Let's just get rid of this real quick for now, so I can make the git diff a little bit cleaner. So let's commit some stuff real quick. That's one of them, and then the other one was instruction. Right? Or not instruction. We modified node. We started modifying node. Oh, that's really inconvenient. Fix fee to use SM node instead of fee node. But yeah. Surprisingly never in Java? I mean, fair. I think that kind of is just like, most people's first experience with Java is just like APCSA, which I also think is kind of why people think it's like a bad language. Like, I think a lot of people form opinions about the language when they're not really like programming mature yet. So that kind of just like sticks with them, especially with like how formative it is in their programming careers. Only know Python, C++, that's fair. I think that's all you really need, to be honest. As long as that fits the jobs that you're targeting. If that's kind of the realm, if you're like looking for like system stuff, then I think that's like a good pile at least. Or like quant even. One friend I have who knows Java learned it in APCSA. Yeah, exactly. Like, yeah, that's kind of how it is. 40% average on compilers final. That's crazy. Our compilers class was like completely project based, so everyone generally did pretty well, but it was like a 20 hours a week class, so it was a lot of work. Some of our like, I think some of our like more math or like theory CS classes have really low averages, but then they get curved up like really insanely as well. So like it kind of evens out. It's like, it's a really strange experience, at least. Okay, so let's go back to what I was trying to do a second ago. Unique putter. Is there any instance where we don't want a unique putter? I think all of these we want a shared pointer, except for like assembly, to be honest, because that one we want to just like transplant in as much as possible. Shared pointer here I think is fine, but I think we need to like, no, I don't think we need to drop the pointers explicitly, so this should still be fine. Can you use move semantics with shared pointer? Yes. That is pretty much the reason I'm using this, at least. I guess, yeah, I have the docs up here, but yeah, so think of it as like, I guess, what even is a good way to understand this? Yeah, so we have the pointer, and then we have a pointer to a control block. Yeah, and that holds like all of the information. The big thing is like pointer count, at least. Honestly, a fun exercise, if anyone wants to learn more about smart pointers, is to just like do an implementation of shared pointer and unique pointer. And I guess weak pointer, maybe. But yeah, I think I'll figure out I'll figure out what the best way to work with these is, but let's replace all instances of unique with shared here. There's only one instance here that I don't want shared pointer. Or actually there's a couple, I think. ASM node, we want to use unique pointer. Oh no. Okay, we can do that. This should also be unique pointer. Yeah, all of this should be unique. Okay. The rest of these, the reason we're using, I guess, smart pointers is because we have descendants that we want to keep track of, or I guess successors, descendants. Those we want to be able to like, I guess we want to be able to like mess around with those when we're merging trees. So that is why we want shared pointers for those, if at all possible. Yeah, this seems fine. The rest of this seems fine. So now we need to actually like do the implementation, which does not seem as fun. We can just replace this with shared, I think. And that fixes most of it. We just need to fix the ones that we broke. Yeah, so let's fix that. It's unique. Down here, we want to fix this. Right? Wait. Wait. Wait, why is this? Oh wait, yeah, this should be no. We should just do shared pointer here. Yeah, we need to modify the tree def as well. DSA class briefly covered smart pointers. That's good stuff. When I learned about shared pointers, at least I did not pay attention. So I very much wish I paid more attention and didn't have to relearn it again. Okay, so we can do this. Why doesn't this work? Oh, this is the wrong type. Whoops. There we go. Alright, I think that's everything fixed then. Yeah, so these are the only unique pointers here, which is good. Alright. Set everything node. Use shared pointers in tree representation with, I guess, leaf pointers. I don't know, we can just do this. I need to format. Whoops. Okay, so we have that now. Sorry, I sound like a dying frog right now. Let's add this real quick. Move, removed. Key node visitor. Okay. So now we can go back to gen trees, which is the thing that we were trying to clean up. Yeah, so we need to be a little bit assiduous with this actually. We need to figure out where we don't want unique pointers. Yeah, so this one, so the one above here, start function is fine. Start basic block is fine because we have like an instructions thing. Resolve value is fine. Oh, wait, no, wait. These are nodes, this is not fine. shared footer. Or I just wrote shared unique. I might be bricks. Does streaming your work help you stay consistent? Yes and no. I think if there is a project that I'm working on, I think I would work on it regardless of whether I streamed or not. With that being said, I think what it does help with is, I guess, making sure I dedicate time to have, or like, I guess, consistent time towards working on a project. Because historically, my motivation's been kind of bursty. Like I would like get really inspired to work on a project and then like tap away at it for like 2 weeks straight, and then I'd be at like a good stopping point, and then I would like put it aside and like not really touch it for a while. I think streaming has forced me to, I guess, be more consistent with that and just like always do a little bit of work on a project. Earlier on, even just during the school year, I did like 4-hour-long streams, which is like I think evidence of that sort of burstiness. But I've started to realize that if I'm like doing this consistently, I can probably get away with like doing shorter streams, or like at least spending less time per day, as long as that lets me, I guess, be more, if I'm like consistent anyway. Do you also read books to learn compilers? Yeah, I've been referencing some of them to at least learn, I guess, like fill in the gaps where I don't know a lot. Currently my knowledge is like very big picture of like what things are supposed to look like, but I haven't like fully internalized a lot of the implementation details, which is, I guess, part of why I'm working on this project as a whole. But like theory-wise, I think I have a somewhat reasonable grasp on a lot of stuff. A lot of the front-end stuff, I think I understand, at least like the compiler-specific part of it. Like the stuff that falls into like more formal PLT, I think I'm a little bit weaker on. But I have a really fun class lined up next quarter, which I think will help address some of that. The middle end, I think I have a rough idea of like how things work simply because of working on this, but also just like reading up on how optimizations are implemented. That's all stuff that like I hope to do more of once I actually get like a functional backend, because I would like to have code that runs, and that would be very cool. And then the backend, I have like a big picture idea of what happens, but I've like forgotten a lot of the details. So it's been a while. So re-implementing it is really good practice for me, at least at minimum. Okay. So yeah, so this resolve value thing, this is a shared pointer now because it's a node. That's really good. All right, now we get to the actual visitors. So binary op, these need to be shared pointers. This is shared pointer. These are shared pointers, right? Yeah, okay. C++. Can we copy a shared pointer? Oh, we can just copy like that. Okay, neat. All right, so then speed. Yeah, okay, this makes sense. Okay, so we can just like make copies of this, I guess. So we can just do that. Yeah, that's valid code. And then we can change this to right leaf. Yeah, okay. So we do that. So this is tree. So we can place that back, and then now we can do this properly. So we can tree get leaves. And now we can insert left. And then we can insert right. Or, yeah, we can do this now. Yeah, and we need to keep these for this purpose alone, I guess. When to use in place back versus pushback. So pushback is just like standard take a thing, or take an object and then it like copies onto back, I guess. I guess like copy, move. It just like you give it an object. That is the important part. In place back, on the other hand, is a construct and, or I guess construct at back. And that's useful for like, I guess just like being more memory efficient. There's a lot of debate on whether you should use them. There's like this, generally you want to use in place back as much as possible, but you can't really use in place back with a move. There's a couple cases where in place back doesn't work. One of them is like when you have something that has to be moved and you can't make a copy of it. Or I guess like, or not even that. Or yeah, if you have like an object that, I think if it requires, or if it doesn't have a copy constructor, I think you have to push back. I think there was like one special case. It might not have been that, but, or I guess just like when you can't really construct the object, that's when you would use pushback. The other big instance is with an initializer list. You can't really in place back an initializer list. You have to just make the thing with the initializer list and then push it back. Those are the big two. There's a surprisingly big, I guess like camp of people that think you should never use in place back. I haven't looked into it. It might be an interesting read, but just know that that exists as well. So it's not the end of the world if you don't use in place back, at least. Here I'm using it because I can, and it seems like it would be somewhat more efficient than constructing it separately and then pushing back. I just found out how much I need to know to become a full stack dev, and it's a lot. Yeah, it definitely is a lot. I think the best way to stay consistent is just to like set smaller, more targetable goals for yourself. It's really easy to like see a mountain and just be like, oh, I want to give up. But you can like separate it down into more concrete steps, like making a JavaScript program, or like writing your first React, or like learning React, or like getting used to like certain databases, or like other web frameworks. I think first thing is breaking it down into these smaller things, and then second is, I guess, finding projects that are meaningful to you in some way. And that, I think, that does a couple of things. The first is it keeps you out of tutorial hell, where like you're just following tutorials and not really like absorbing anything from them. And the second thing is that like, if you pick good projects, they will be something that is interesting to you, and that means you will naturally be incentivized to work on whatever it is because it's cool and you want to work on it. So that's like my, I guess, top level advice that I can give on that. Also, projects go great on a resume, so they don't even need to be great projects. It just needs to be something. That is the best way to learn. Just in my experience, I think you can't beat just working on projects. Okay, this has no children nodes that I think we can use. Yeah, of course, let me know if you have any other questions about, I guess, learning a bunch of software stuff. I can only do projects based on things I'm very interested in, super into college football. Yeah, that's like a perfect example, I think. I think like one of the other projects I want to work on, which I haven't gotten a chance to start yet because I have like 3 other projects I'm working on currently. But one of the projects I've been looking at is like, I saw this like baseball CLI thing. Yeah, this thing. So there's a CLI tool to display this, or like, I don't think it was this. There was another one. there's a really funny one. It was like stats. It's not that. It's not this. Let me find it. Sorry, just give me a second. I'm gonna pull it up. But it was like a command line tool to like, I guess like get baseball related utilities in your console so that so you could like put it in your like Tmux config, which I think is just really funny. Let me find it. It shouldn't be that long. Just need to scroll a little bit. Someone I know started it, so where did it go? It's not that. It's not that. Damn it. Okay, this is actually very important to me, so I need to find it. But I was thinking of making a similar tool for like Valorant, and I thought that would be just like a really funny thing to work on. Has image. Ah, found it. Okay, let me make sure I'm not like leaking my DMs. Play ball. Yeah, this one. Yeah, so it's just a terminal interface for like baseball games. But the useful thing is you can like, there should be ways to like a CLI thing to, I guess, like, just like pull specific game stats or something like that. And the idea is my idea is we can kind of just do something similar, but with like, what's it called? Something similar for like VLR or like HLTV for like Counter-Strike. And I think that'd just be really funny if you saw in like my Tmux config, just like on the upper right here, instead of like device and like date, which I kind of already know, I don't need to stare at my config for, if it was just like the score of like the most recent game on like VLR. And I just think that'd be so funny to have. Do you think it's worth it to learn full stack? I think it's still pretty worth it. Like the job market is rough for the average person, but if you're very cracked, it will always be good for people that are cracked, I think. So if it's something that you're like genuinely interested in, I think it's still worth learning. If you're doing it just for like the money as like a means to an end, I don't think it is worth doing. Yeah. So Allocate should have no children, I think. Or maybe I could give it size as a child. Yeah, I guess that would make sense. Or actually no, we can just leave it as is. I don't think I'll optimize that too much, at least beyond this point. I don't think it matters, it's a constant. Also, yeah, Blueberries is right. The job market does make it seem a lot worse than it is. It is just like, you have to like, you kind of just have to go through it at the end of the day. What rank are you in Val? Currently I'm Diamond 2, I'm Peak Ascendant 1. I'm a little bit washed. I don't play a lot anymore because school. But I still follow like the pro scene a lot. It's pretty cool to me. Okay, so this needs the pointer as the child. We should take this. Yeah, so we need to ref that. It's gonna get leaves. I'm gonna push back. Putter. Or leaf. And this is a shared pointer. Okay, perfect. Wait. Oh, insert. Whoops. What's this at? The only thing I'm concerned about here is like a diamond dependency thing, but I don't think that should be possible, at least, given the algorithm that I'll be using. Okay, maybe I should just be responsible and do the thing properly here as well. So use that. And then tree. We can steal this. So use that as well. Oh, this is shared. Did we miss any? I think we missed one. Aha. Yeah, we did miss one. Okay, that one's good. Or these are good as well. These are good. This is good. This is shared. This is... Yeah, this is assembly, so this is good. Allocate. This should be shared anyway. Yeah, okay. This is all load, shared, shared. This is store. Actually, no, I should not insert. I should not insert this. And allocate. If I need this in the future, I will do that. But for now, I don't think I need it. Okay, so we have... Yes, we have... we just fixed load, I think, yeah. So now we need to fix store. The source is the putter. Or this is what we care about, I think. We care about that and putter, actually. Yeah, so we want to... Is there an order I cared about? Not really. So we should do this as well. Let me just clean this up a little bit. Putter. This is or a leaf, actually. So we need that. And then unique. Shared. Yeah, I guess there's a joke about collectivism to be made here. I hit the wrong button. Whoops. So we do that. Yeah. Okay. And then leaves. Insert source leaf. Yeah, this is a dot. Whoops. Okay, and then this should be putter leaf. Okay. The fee instruction is assembly, so that's fine. Return is assembly, so that's fine. Branch is assembly, so that's fine. Con branch is assembly, so that's fine. Okay, cool. I think that's everything at least. Hopefully nothing breaks. It'd be very tragic if something were to break. Yeah, and then this will enable us to do tree merging properly, which is really funny because I think I'm out of time to do that today. Do tests pass? They do pass. Okay, so that at least works. Yeah, so let me just like double check again. This should be fine. These are both shared. Binary up. So this is shared, and then it has an inserts at the bottom, so that's fine. This is shared. It doesn't have insert, which is fine. This is shared. This has an insert. This is shared. This has insert. Yeah. Okay. That's all. Yeah. Okay. Use shared putters in Gentry. Okay. Alright. I think that's a good place to call for today. I'm really hungry and I've It's been a hot second since I've eaten, so I'm gonna go address that and also get some water because my throat, I sound like a dying frog right now. Thank you all so much for showing up for today's stream. Make sure to like the stream if you haven't and sub to the channel. While you're down there, join the Discord. It's the best place to get pinged when I go live and chat with me and the community outside of stream hours. And of course, make sure you add me on GitHub and connect with me on LinkedIn. Yeah, that's about it. Take care, y'all. Take it easy and have a wonderful rest of your day wherever you are.